Hello everybody, this is just a video showing the answer key being made. Not required to see, you can only to watch this if you want some help or if you want to see the kind of process to go through to solve these problems. So I'm going to start off with problem 26 here. We have these two vectors here, and the directions for 26: find the vector projecting v onto v, then write u as a sum of two orthogonal vectors. So orthogonal perpendicular vectors. Let's start by getting a visual of this. So if we sketch out these vectors, vector v is at -2, -6. So that would roughly look like this. And vector u is at 3, -7. So that is down here. We're projecting u onto v. So that means we're going from here to make a right angle with vector v. I'm thinking maybe about there-ish is about where that right angle is. So this vector ultimately should be in the same direction as v, but maybe just a little bit shorter. In order to find out what that projection is, we're going to use the formula that you guys did in class yesterday. The projection of u onto v is equal to the dot product divided by the magnitude of v squared times vector v. So the dot product would be -6 plus 42 divided by the square root of 40 squared. This becomes 36 out of 40, which is 0.9. So this 0.9 represents the scalar that we're going to multiply into vector v. So if I take that 0.9 and multiply it into -2, -6, I end up with -1.8, -5.4. What this represents right here is the vector starting at the origin and going up to this point right there, where the orthogonal perpendicular vector met vector v. So this is one part of the answer, and this would have been the answer to yesterday's questions. The thing that's in addition to this is we want to find out how to express u, this vector, as a sum of two orthogonal vectors. Well, this diagram has two orthogonal vectors that if we add them together, we would get vector u. The only thing missing is this blue vector here, the one that's orthogonal to this vector and connects to u. The quick way of doing this is just subtraction. So if we take vector u and subtract the projection, that'll get the orthogonal vector. So vector u, 3, -7. I'm going to subtract this guy, the projection, and 3 minus -1.8 is positive 4.8, and -7 plus 5.4 is -1.6. Let's just see if that kind of makes sense here. So if we start here and go in this direction about 4.8 down -1.6, that does make sense that that would be the other vector. So those are our two answers. To express it as a sum, we can just write the final answer as -1.8, -5.4 plus 4.8, -1.6. Okay, 28 is going to be the same process, so let's get into it. Getting a visual first. Feel free to pause this video if you want to try it on your own first. -2, 8 is up here. So that is my vector u. My vector v is 9, -3. So about there. This visual is a little bit more complicated because in order for us to project onto vector v, in order to make it a right angle, we have to extend it a little bit. So if we extend vector v here out that way, if we're going to make a right angle from here, it would actually look something like this. So the answer to this question is actually going to go in the opposite direction that v is initially headed. So it's going to be actually in quadrant 2 as a final answer. Let's get to the math now. So just keep it in green. Projection of u onto v is the dot product times v. U dot v is going to be negative 18 minus 24. Magnitude of v is going to be 81 plus 9, so that's 90. And negative 30, it's going to be negative 42 over 90. I believe that does reduce a little bit at least. Negative 14 over 30, negative 7/15. So if we take that negative 7/15 and multiply it into 9 negative 3, that would be negative 63 divided by 15 and positive 21 over 15. Reducing this a little bit, it would be negative 31/5, comma 7/5 as our final answer. To put this into decimal, I guess that would be negative 6.2. It's okay if you guys use a calculator for this. And this would be 1.4. Let's see if that makes sense. Negative 6.2, 1.4. If we go out this way, negative 6.2 up 1.4, that does appear to be this projection, this green projection vector there. So now what we need to do is we need to find out what this vector is that connects to u in order to answer the question, similar to what we did up there. So I'm going to take u, negative 2.8. I'm going to subtract the vector we just got, negative 6.2, 1.4, and I get, that becomes positive 4.2, comma 6.6. Let's see if that makes sense. So this other vector would start here, go about 4.2 this way, up 6.6. That does make sense. And our final answer will be negative 6.2, comma 1.4 plus 4.2, comma 6.6. And do a similar thing for 25 and 27 and check your answers in the back. Okay, moving on to problem 44. So this is one where you're going to use some different skills. We haven't done one exactly like this, but if you just kind of apply what you know, you can get the answer. So this is the given information, and they want to know what vector v is. So what I'm going to do is I'm going to make up a vector v. I'm going to call it x comma y to represent its components. If u dot v is negative 11, that would mean that negative 2x plus 5y equals negative 11. If the magnitude squared is 10, that would mean that x squared plus y squared is equal to 10. From here, this is going to be a systems of equations problem. It's not going to be a fun one. So we're going to first isolate, let's say, the x over here. So we get 5.5 plus 2.5y for x. We can substitute it in here. And then I'm going to have to use a calculator here. 5.5 squared. 30.25. 5.5 times 2.5 is 13.75. There's going to be two of them. I'm just foiling. And then 2.5 squared is 6.25 y squared. So tightening this up a little bit and subtracting the 10 over, I would get 7.25 y squared plus 27.5 y and then minus or plus 20.25 equals 0. I'm going to multiply all these by 4 to avoid decimals. So I'd get 29 y squared, 110y, and 81 equals 0. One option you could do is you could plug this into y equals and find out what the intersection is. I'm just going to do it algebraically. X equals negative 110 plus or minus square root of 110 squared minus 4 times 29 times 81 all over 58. I'm just going to type this into the calculator. And I get exactly negative 1. Apparently that factors. How about that? Then if I do the subtraction value, I get negative 162 over 58. Which is negative 81/29. Okay, so now for the y value, I'm going to plug it back into this equation over here. We'll just maybe go to this one instead. So x equals 5.5 plus 2.5 times negative 1. That's 3. So this is really the y value there. So one vector is 3 comma negative 1. Oh, that checks out with this equation too, so that is an answer. Now as far as negative 81 over 29, let's see what happens when we plug that in. And I get negative 43/29. So that means another vector is negative 43 out of 29, comma negative 81 out of 29. Let's use Pythagorean theorem to make sure that this works. So I'm just going to put in my calculator, 43 divided by 29 squared plus 81 over 29 squared. And I get 10, so this one works as well. So there's two answers to this question. Took a while to get there, but there they are. Okay, good luck. Send me a Schoology discussion question if you have anything. If you have a question, I'm sure somebody else does too. Talk to you later.